Good day, everyone. I'm Kathleen John Benavista, and I'll be your reporter for today. So now let's discuss highway soil and bituminous materials under the pavement design. So first, let's define pavement design. Highway pavements are constructed of either asphalt or concrete and ultimately rest on a native soil that is either hard, smooth, and leveled surface made. Pavement design is major component in the road construction, nearly one third or one half of the total cost of the construction, so that careful consideration should be taken in the design of the pavement. So before we proceed to our discussion, let's have our objectives first. So we have to familiarize the properties and structural characteristics of the materials in pavement design, and also to study the methods and theories for the design of heavy-duty asphaltic concrete pavements and various treatment strategies for low-volume roads. Highway soil and bituminous materials. Bituminous materials are usually used widely all over the world in highway construction. It consists primarily of bitumen and have strong adhesive properties. Its color ranging from dark brown to black. And also bitumen materials are usually fairly hard at a normal temperature, and when it is heated, they soften and flow. Also, it varies in consistency from liquid to solid. So from solid form, it is usually hard and brittle at normal temperature, but if it will heated, it will flow when subjected to long, continuous loading. While in liquid form, it is obtained from the semi-solid or solid forms by heating, dissolving it in the solvent, or breaking the material into minute particles and dispersing them in water together with the emulsifier to form an asphalt emulsion. Bitumen possess a number of properties that make in the construction industry. So in this chapter, we will discussing about the different types of bituminous materials used in the highway construction and also the processes by which it was obtained. So first, let's have the sources of asphalt. So we have two different resources of the asphalt, the natural deposits and the petroleum asphalt. So asphalt, also known as mineral pitch, it is obtained from either natural deposits such as a native asphalt or brea, or is a byproduct of the petroleum industry or petroleum asphalt. So it is obtained from seeps or pools of natural deposits in different parts of the world or as a product of the distillation of the petroleum crude. So under the natural deposits, we have two types, the native asphalt and the rock asphalt. Native asphalt was one at one time used extensively as binder in highway construction. It is also being softened with a petroleum fluxes. The properties of native asphalts vary from one deposit to another, particularly with respect to the amount of insoluble material an asphalt contains. So it is also known that it is existed in Iraq several thousand years ago. So we have different types of native asphalt. We have here the Trinidad deposit, which contains about 40% of the insoluble organic and inorganic materials, and also the Bermuda material that consists of 6% of this material. Next one is the rock asphalt. Rock asphalt is a natural deposit of sandstones or limestone rocks filled with asphalt. So the amount of asphalt varies from one deposit to another. So it is the same from native asphalt. It can be used to surface roads after the mined or quarried material has been suitably processed. So this process includes adding suitable mineral aggregates, asphalt binder, and oil, which facilitates the flowing of the material. And rock asphalt is not used widely because of its high transportation cost. Next, we have here petroleum asphalts. Asphalts, materials obtained from distillation of petroleum, are in the form of different types of asphalts. So the quantity of asphalt obtained from crude petroleum is dependent on the Material Petroleum Institute or API gravity of the petrol. So, in general, the large quantities of asphalt are obtained from the crude petroleums with low API gravity. So, before discussing the properties and the uses of different types of petroleum's asphalt, first let's describe the refining processes of this petroleum asphalt. So, refining process used to obtain petroleum asphalt that can be divided into two main groups. The first one is the fractional distillation. Fractional distillation is a process involved the separation of the different materials in the crude petroleum without significant change in chemical composition of each material. So it removes different volatile materials in the crude oil at successive high temperature until the petroleum asphalt is obtained as a residue. Steam distillation is a continuous flow process in which the crude petroleum is pumped through the tube stills or stored in batches, and the temperature is increased gradually to facilitate the evaporation of different materials at different temperatures. Next one is the destructive distillation or the cracking. It is a process involving the application of high temperature and pressure resulting in chemical changes. Cracking processes are used when large amounts of light fractions of materials, such as motor fuels, are required. The asphalt obtained from cracking is not used widely in paving. So, to remove the removes the different volatile materials in the crude oil at successive higher temperature also until the petroleum asphalt is obtained as residue. And also, the intense heat and high pressures are applied to produce the chemical changes of the material. So we have here the description and the uses of bituminous materials. Bituminous asphalt. So bituminous material or what we call bitumen is a solid, semi-solid or viscous cementitious material or as a binder, a natural or manufactured and composed by hydrocarbons and soluble in carbon disulfide. It is necessary at this point to describe the different bituminous binders and identify the type of construction for which it is used. So these hydrocarbons that are found in the natural deposits are obtained as a product of the distillation of crude petroleum. So the bituminous materials used in highway constructions are either asphalt or tars. So we have here different types of asphalt. First, we have the asphalt cement. The second one is the asphalt cut box. The third is emulsified asphalt. The fourth is blown asphalt. And lastly, the road tar. First, let's discuss the asphalt cement. Asphalt cement, it is also called paving asphalt, are the primarily asphalt products produced by distillation of crude oil. At ambient temperatures, asphalt cement is black, sticky, and semi-solid and a highly viscous material. It is also strong and durable cement with excellent adhesive and waterproofing characteristics. So the largest use of asphalt cement in the production of asphalt concrete, which is primarily used in the construction of flexible pavement throughout the world. Next, we have here the asphalt cut box. Asphalt is simply a combination of asphalt cement and the petroleum solvent, and it is used because it can reduce asphalt viscosity for lower temperature. After a cutback asphalt is applied to the petroleum solvent evaporates, leaving behind asphalt cement residue on the surface to which it is applied. So a cutback asphalt is said to cure and the petroleum solvent evaporates away. So it uses asphalt seals such as tack coats, fog seals, slurry seals, and other stabilizational material. So we have three types here of asphalt cutbacks. We have the slow curing cutback asphalt. medium curing cut-box asphalt, and rapid curing cut-box asphalt. So, slow curing cut-box asphalt can be obtained directly as slow curing straight run asphalt through the distillation of crude petroleum, or as slow curing cut-box asphalts by cutting back asphalt cement with a heavy distillate. So they have lower viscosities than the asphalt cement and have very slow harden from the word slow curing. So it is called road oils and are used primarily in road mixing and dust laying applications. This term originated when asphalt residual oil was used to give roads a low-cost, all-weather surfaces. So, slow curing cutbox asphalts are also used for stockpile patching mixes, plant mix with graded aggregates, and occasionally for priming. Next, we have the medium curing cutbox asphalt, harden faster than slow curing material. So it is designed to mix with aggregates because these grades do not break immediately upon contact with aggregate. Mixing using medium setting cutbox can remain workable for extended periods of time and will lend themselves to cold mix stockpiles. So in other words, medium curing is better than slow curing. It's faster also. And lastly, we have the rapid curing cutbox asphalt. It is produced by blending asphalt cement with petroleum distillate that will evaporate easily. So from the word rapid, it is designed to react quickly and are primarily used in spray applications such as bond or tack coats, aggregate chip seals, sand seals, granular priming, and similar surface treatment. So next we have here the emulsified asphalt. Emulsified asphalt, also simply called emulsion, it is a mixture of asphalt cement, water, and emulsifying agent. It is produced by breaking asphalt cement, usually to from 100 to 250 penetration range, into minute particles and dispersing them in water with emulsifier. So asphalt emulsions generally are classified as anionic, cationic, and non-ionic. So the first two, which is the anionic and cationic, have electrical charges surrounding the particles, while the anionic, it is a type that is neutral. So anionic and cationic asphalts, it is generally are used in highway maintenance and construction, while the non-ionic used more frequently in the future as emulsion technology advances. Next, we have the blown asphalt. Blown asphalt is obtained by blowing air and the semi-solid residue obtained during the latter stages of the distillation process. So the material is maintained at high temperature while air blown is through it. So blown asphalt generally is not used as paving materials. However, it is very useful as roofing material for automobile, undercoating, and as a joint filler for concrete pavement. Road tars. Tars are obtained from destructive distillation of such organic materials as coal. So their properties are significantly different from petroleum asphalts. Tars now are usually reared for highway pavement. The American Society of for Testing Materials, or ASTM, has classified road tars into three general categories based on the method of production. So first, we have the gas house coal tars. It is produced as a byproduct in gas house retorts in the manufacture of illuminating gas from bituminous coals. Next, we have the coke oven tars. It is produced by as byproduct in coke ovens in the manufacture of coke from bituminous coal. And lastly, we have the water gas stars that is produced by cracking oil vapors at high temperatures in the manufacture of carbonated water gas. So now let's proceed to the properties of asphalt. So the properties of asphalt materials pertinent to the pavement construction can be classified into four major categories. We have the consistency, the aging, and the temperature sustainability, the rate of curing, and the resistance of water action. So the consistency properties have um, considered under two um, general conditions, which is the variation of consistency with temperature and the variation of consistency at specified temperature. So first, let's have the variation of consistency with temperature. So the consistency of any asphalt materials changes as the temperature varies. The change in consistency of different asphalt materials may differ considerably even for the same amount of changes. So for example of it is that we have two different types of materials. We have the blown semi-solid asphalt and the semi-solid regular paving grade asphalt. So with this, we have the same consistency at the given temperature. So they are heated together in a high enough temperature. And then the consistencies of the two materials will have different um, at the high temperature. So for, for regular paving, asphalt is much softer than the blown asphalt. So if these two asphalts are cooled down gradually to the freezing temperature of water, the blown asphalt will be much more softer than the regular paving asphalt. Thus, the consistency of blown asphalt is affected less by temperature changes than the consistency of the regular paving grade asphalt. So, they have different consistencies. This property of asphalt materials is also known as temperature susceptibility. So, temperature susceptibility means the viscosity of the asphalt decreases as the temperature increases. The asphalt hardens and becomes brittle when the temperature goes down, and the asphalt softens at a higher temperature. So the next one is the variation of consistency at specified temperature. So the consistency of an asphalt material will vary from solid to liquid depending on the temperature of the material. It is therefore essential that when the consistency of an asphalt material is given, the associated temperature should also be given. So next we have the aging and the temperature sustainability. When the asphaltic materials are exposed to environmental elements, natural deterioration gradually takes place and the materials eventually lose their plasticity and become brittle. This change is caused primarily by chemical and physical reactions that take place in the material. So this natural deterioration of the asphalt material is also known as weathering. So, for paving asphalt to act successfully as a binder, the weathering must be minimized as much as possible. So, the ability of an asphalt material to resist weathering is described as the durability of the material. So, some of the influences of the weathering are the oxidation, volatilization, temperature, and exposed surface area. So first we have the oxidation. Oxidation is the chemical reaction that takes place when the asphalt material is attacked by oxygen in the air. The chemical reaction causes gradual hardening or eventually permanent hardening and considerable loss of the plastic characteristic of the material. Next we have the volatilization. It is the evaporation of the lighter hydrocarbons from the asphalt materials. The loss of these lighter hydrocarbons also causes the loss of plastic characteristics of asphalt materials. Next, we have the temperature. It has been shown that the temperature has a significant effect on the rate of the oxidation and volatilization. The higher the temperature, the higher the rates of oxidation and the volatilization. The last one is the exposed surface area. The exposed surface area of the material also influences its rate of oxidation and volatilization. There is a direct relationship between the surface area and the rate of the oxygen absorption and loss due to evaporation in grams per cubic centimeter per minute. An inverse relationship, however, exists between the volume and the rate of oxidation and volatilization. So this means that the rate of hardening is directly proportional to the ratio of the surface of the area of the volume. So next we have here the rate of curing. Since asphalt needs time to harden and cure, usually 6 to 12 months to fully cure, your parking lot or driveway will remain soft and pliable until then. So it remains a little more susceptible to damage for that time. However, it takes 48 to 72 hours to dry enough for foot and vehicle traffic. And lastly, we have the resistance of water action. For the conventional bitumen, stiffness decreases slightly and the energy increases. These results indicate that the mixture subjected to the moisture damage has greater resistance to cracking than the unconditional one. The water action may cause a slight aging of bitumen as a result of the temperature of the water bath. So when the stiffness increases, also the energy increases. For this type of mixture, the effect of the water results in the slight aging that is not enough to cause severe damage. So it is really okay for that. So that's all for my report. I hope you have learned something new from this discussion. And thank you for listening. That's all. Bye.